So we're still dividing square roots on this problem. However, we have a binomial in the denominator. And so on this one, it's not enough just to multiply by the square root of 2, because if I did, I would have to distribute that square root of 2 to the 3 also, and I'm still going to have a radical in my denominator. So what I have to do is something called multiplying. We're going to multiply numerator and denominator by the conjugate. And what the conjugate is, this was 3 plus root 2. The conjugate is 3 minus root 2. The only thing that changes is instead of a plus sign, here it's going to be a minus. If this had been a minus, then the conjugate would have been 3 plus root 2. So it's just the opposite sign in the middle. That's the only thing that changes for the conjugate. So I'm going to multiply the numerator and denominator, because I still have, whatever I do to the denominator, I have to do to the numerator. And the reason I'm going to do that, you'll see here in a minute, when I multiply this, now this is a binomial times a binomial, which means, put it in a box. So I have 3 plus root 2 times 3 minus root 2. 3 times 3 is 9. 3 root 2. And here we have a negative 3 root 2. And root 2 times root 2, remember when you square a square root, they undo each other and you just left with a 2, but it was negative. Now I'm adding like terms, so I have a negative 3 root 2 plus a 3 root 2, and these will cancel out. And the nice thing about multiplying conjugates is they will always cancel out. So we end up with just 9 minus 2, which is 7, which is great because remember, we needed to have a denominator that didn't have a radical in it, and so now we do. But I still have to multiply the numerator, so I'm going to distribute. 4 times 3 is 12, minus 4 times root 2. So my answer is 12 minus 4 root 2 all over 7. And that's my answer. Notice that I no longer have a radical in the denominator. And again, the process I used was to multiply by the conjugate. And what will always happen is when you multiply by the conjugate, you will always drop out that term that has the square root in it. So on this problem, the conjugate is 4 plus root 3. So in the denominator, if you put this in a box, we have 4 minus root 3, 4 plus root 3. We'll have a 16, negative 4 root 3, and a positive 4 root 3. Square root of 3 times the square root of 3 is 3, and we have a negative. These cancel out, so 16 minus 3 is 13. And I distribute the 5. 5 times 4 is 20. And here I get 5 root 3. And that's my answer. Now I want to show you a shortcut. Since the square root of 3 terms will always drop out, we can really just do a shortcut and take 4 squared minus, and if you take the square root of 3 squared, and we get 16 minus 3 is 13. And the reason that's the case is notice that I have 4 plus root 3 times 4 minus root 3. Well, that's the form for the difference of 2 squares. So I can simplify that by just doing the difference of 2 squares. 4 squared is 16, and when I square a root 3, I get 3. 16 minus 3 is 13. So that's a shortcut that some of you might want to use. If you have a hard time using that shortcut, put it in a box. So on this problem, The conjugate is the square root of 3 minus 2. Now, the conjugate is always going to be determined by the denominator, not the numerator. So here I'm still going to multiply the square root of 3 minus 2 in the numerator. So for my denominator, I'm going to use my shortcut. If I square the square root of 3, I get 3. And if I square a 2, I get 4. And 3 minus 4 is negative 1. So that's going to go in the denominator. If you have trouble with that, put it in a box. And for my numerator, I have to put it in a box because I have, or FOIL it, I have a binomial times a binomial. So we have 2 minus root 5 and the square root of 3 minus 2. So here I'll get 2 root 3, negative root 15, because remember you can multiply the square roots, they don't have to be the same. 2 times negative 2 is negative 4, and here I have a negative times a negative, so it's going to be a positive 2 root 5. Notice there are no like terms, which means I'm going to have 2 root 3 minus root 15 minus 4 plus 2 root 15. Oh, sorry, 2 root 5. Okay? Now, that's all over a negative 1. When you divide by a negative 1, you're not changing the numerical portion of it. However, just like when you multiply by a negative, it changes all the signs. So you will likely see an answer written like this: negative 2 root 3 plus root 15 plus 4 minus 2 root 5. Dividing by negative 1 would be equivalent to multiplying by negative 1, which changes all the signs. So this would be a better answer. Conjugate is 3 plus root 5. Whatever you do to the denominator, you do to the numerator. I'm going to do the shortcut here. 3 squared is 9, minus the square root of 5 squared is 5. So I'm going to have a 4 in the denominator. And to get the answer in the numerator, I've got to put this in a box. So we have negative 3 minus root 2 and 3 plus root 5. So we'll have negative 9 minus 3 root 2 minus 3 root 5. And remember, here we're just going to multiply the square roots. And once again, there are no like terms, so we have negative 9 minus 3 root 2 minus 3 root 5 minus root 10, all over 4. Nothing to simplify, and the order of these would not matter. Last example, the conjugate would be 2 plus 5 root 2. So in the denominator, I'm going to do my shortcut again, but you're going to have to be careful. 2 squared is 4 minus, now I have to square the 5 and I have to square the square root of 2. So 5 squared is 25. The square root of 2 squared is 2. 25 times 2 is 50. So I end up with a negative 46 in the denominator. And again, you can put this in a box and you'll still get that same answer, but if you have trouble with the shortcut, then you might want to do that. So for my numerator, I have 3 root 3 plus 3 and 2 plus 5 root 2. So I multiply, I get 6 root 3. Here I get a 6. Now I'm going to multiply the whole number part, so 5 times 3 is 15. Root 3 times root 2 is root 6. And here I get 15 root 2. And once again, there are no like radicals, so I just have 6 root 3 plus 6 plus 15 root 6 plus 15 root 2 all over a negative 46. And that's okay if you told me that for an answer, but you will often see it written where you won't have a negative sign in the denominator. Instead, you could just put it out front. So you might see that, I'm going to actually erase this and show you so I don't have to copy everything over again. You might see the negative sign written here instead, just to show you that the whole quantity is negative. Or sometimes you can even see the negative sign in the numerator and have it distributed where all the signs would be opposite. So any of those ways would be fine.